Hello everyone, my name is Anindya. Welcome to my YouTube channel. Today we will discuss about readers writers problem in C programming. First of all, what is readers writers problem? Readers writers problem is a standard problem of process synchronization in operating system. To understand this, first of all, we need to understand the database. Suppose here is the database DB. There is a database DB. Database is a collection of related data. Suppose many user can access the database at the same time. There are two type of user, that is readers. They only want to read the data from the object, and there is another one is writers. They want to write into the object. Suppose there is R1, W1, R2, W2. Any user want to access the database at the same time, then a problem will occur. If two readers access the object at the same time, there is no problem. However, if two writers or readers and writers access the object at the same time, there may problem occurs. To solve this situation, a writer should get exclusive access to an object. Suppose a writer is in the database and one reader want to read the database at the same time. If it enters into the database, then there will be a problem. Then a problem will occur. To solve this problem, a writer should get exclusive access to an object. But the writer is access the object. No writers may access it. However, multiple readers means any reader is present into the database. At that time, any number of readers, so R1, R2, R3, any number of readers can access into the database. There will no problem occur. In the next slide, we will understand the four types of problems in the readers writers problem. First is writing problem. Suppose there is a user is performing a write operation into the database and another user want to perform the write operation into the database. If the situation happens, then a problem will occur. The next case is a writing reading problem. If a reader is performing a write operation into the database and another user want to perform a read operation into the database, then a problem will occur. The fourth case is reading problem. But it is not a problem, it is allowed because in the previous slide I saw that if a read operation is happening in the database, then any number of reader can access the database at the same time, any number of readers, so it is not a problem. So first case is writing problem. So it is the code for writer process, and first case is writing writing process. So it is the code for reader process. We know that if any process try to enter the critical section, then the process have to perform the entry code and also while exiting, the process have to perform the exit code. So the it is the critical section in the middle, and above that it is the entry code and it is the exit code. If any reader process try to enter the critical section, then they have to perform first the entry code, and while exiting they have to perform the exit code. So our first problem is writing problem. So if any writer try to enter in the critical section, then they have to perform this code. First is wait WRT, wait write. So what is the write value? First write value is 1. Write value is 1. So wait write value means write value will be decreased 1 to 0, and the writer will enter the critical section. If another writer, suppose W2, try to enter in the critical section, they have to perform the same code. So while entering, wait write. So the program have to decrease the write value, but the write value is already decreased. They can't be negative. That's why W2 will be blocked. This case is properly working for case 3 writing problem. So now let's understand the second case. So what is the second case? Writing reading problem. First, writer will enter the critical section. So if the writer entered in the critical section, first is wait write. So what is the write value at the initial? Write value is 1. So it will decrease and it will be 0. So writers enter in the critical section. Now readers, so now the reader will try to enter in the critical section. But first it's perform wait mutex, means mutex value is first 1, it will be decreased to 0. Next it will go read count plus plus, means read count will be increased to 0 to 1. And next, if read count is 1, then wait write. Here read count is 1, but write is already 0. So it can't be decreased because it is a binary value, it can't be negative. So wait write will be failed. So reader can't be entered into the critical section. So for our case 2, the code is succeed. Now understand the third case, reading writing problem. Reading writing problem. The first reader will be entered into the critical section. When reader will enter, the mutex value, wait mutex means the mutex value will be decreased. The mutex is 1, it will be 0. Next is increment read count. Read count will be 0 to 1. If read count is 1, then wait write. Here read count is 1, wait write. The 1 will be decreased to 0. So the reader will be entered into the, and the signal for mutex means mutex value will be again 0 to 1, and the reader will be entered into the critical section and perform the reading operation here. Again, when the writer try to enter into the database means the critical section, the writer will perform the write code, and here at the initial it will perform wait write, means write value will be decreased, but here write value is already decreased, it is already 0. So writer will be blocked here. So for our case 3, the code is successful. Now let's understand the case 4, reading. So now it is reading. So first, suppose reader 1 is trying to enter in the critical section. First is what? Wait mutex, means mutex value will be 0. Read count, increment of read count will be 1. If is read count 1, yes, read count is 1. So wait write will be 0. Signal mutex will be increased 0 to 1, and reader 1 will enter into the critical section. Suppose another reader R2 is trying to enter into the critical section. So first is what? Wait mutex. What is the mutex value? It is 1. So mutex value will be decreased 1 to 0. Read count will be increment 1 to 2, because 2 readers is entering into the critical section, that's why it is 2. Is read count equals to 1? No, it is not 1, it is 2. So it will not run that. Now is signal mutex. Mutex value will be increased. If value is 0, it will be increased to 1, and R2 will be enter into the critical section. So there is no problem. So our case 4 is also successful. Now let's understand the code for exiting a reader, means this part. Now suppose R2 is finished his work and want to exit from the critical section. Now it will perform that code. First is what? Wait mutex, means mutex value will be decreased 1 to 0, and read count will be decreased because one reader is exiting from the critical section. For that, read count will be 1. Is read count equal to 0? No, read count is not 0, it is 1, because reader 2 is already present in the critical section. So it will not perform this part, and it will perform this one. Signal mutex, yes, mutex will be 1. Now let's understand the C programming for readers and writers problem. As I gave more time to understand the pseudocode, and I modified the pseudocode into the C programming language, so the logic is same. So you will understand it very easily. First is, in this program we are using 10 readers and 5 writers. Here I am using two semaphore, write and mutex, and one variable count. It is a shared variable, and number readers. It is a number of readers present in the critical section. So initially it is 0. Now come to the code for writer. So this wait operation is same as the semaphore wait, and the count is the shared variable, and we are modifying it here, and here we are printing the number of writers and the number of count, and at last the post operation is same as the semaphore signal. Now it is the reader code. So first it log the mutex and increment the number of reader. If it is the first reader, then it will block write. Next it will unlock the mutex and perform the reading. And now here it will print the number of reader and count. And if the reading operation is done while leaving the critical section, it will again log the mutex and the decrement the number of readers, and if it is the last reader, it will signal to the give the signal to the write operation, and at last it will unlock the mutex again. So now come to the main function. So first it is a readers and writers threads. As we take 10 readers and 5 writers we declared here, and now we initialized the mutex and semaphore also. This is a binary semaphore. That's why here is 0 and 1. The 0 and 1 is representing whether you want to share this semaphore with multiple threads or not. 0 is representing is you want to, and 1 is representing not. This array is just for numbering the readers and writers. And in this for loop, we are creating 10 readers, and first of all we are in this function we are
pass the reader's name and the reader's function that the thread will execute, and here it is I am passing the thread number as same as the for writer also. Here I am declaring 5 writers. After that we are joining both readers and writers, and before leaving this code we are destroying the mutex and writer. So I hope you have understood the code and the concept of readers and writers problem. So at last I will say that please subscribe to my channel, and if you like this video then give it a like. Thank you.